So yeah, hello. My name's Dan. I'm going to give a talk about PHP value objects and you. I'm going to start my stopwatch so that I don't end up talking for 2 hours. And yeah, so my name's Dan. I've got a company as of 2 years, and I just do software contracts really. I do a lot of programming, so I do programming in PHP and more recently in Rust and a little bit of Golang and stuff like that. I maintain 2 open source projects. One of them, maintain, quotation marks. One of them is Factor, which is like a language server. So it's like the intelligent part of PHP Storm, the thing that does the completion, the go-to definition, and the refactoring and all that sort of thing. But for Vim, Emacs, and VS Code, and yeah, these sort of things. And PHP Bench, which is like a benchmarking tool that's used by a lot of projects in the open source ecosystem for PHP to test the performance of those projects. And about 500 other projects that you've never heard of and which are just rotting on my GitHub account. So I like running, and this is me enjoying my hobby. And this talk is PHP value objects and you. So PHP, I mean, it's a bit redundant. This is a PHP meetup. So we're talking about PHP. Value objects, because it's about value objects, and you, because you might use value objects, I guess. So why am I giving this talk? I'm giving this talk because I was in a lot of meetings where people were kind of discussing value objects, saying, oh, well, how do we introduce value objects into our projects? And, what interfaces do we need in our value objects to bring them into the project? What abstract classes do we need to create? Where should we put the value objects? And I'm like, just create a value object. Like, I don't ask permission to create value. I just use value. It's just a tool that's in your toolbox, right? I use them all the time. And I use them all the time because they're part of something that I call like modeling, right? So modeling is a way to describe and represent the problem that you're trying to solve. And you've got a toolbox. So just like any artisan, right? You're building something, you've got a toolbox, and you've got these tools, these design patterns that you can use to solve the problems, to model the problem that you're confronted with. So these might include value objects, adapters, entities, collections, DTOs, factories, whatever, right? These are the tools in your toolbox. And what's modeling? So I kind of like to think like, I think this is Michelangelo. He says something like, you've got a big slab of marble, a big block of marble, and he's trying to look inside of the marble to find the form within the marble, right? And I think this is similar to problem solving, right? We've got a problem, and we can kind of see this big thing, which is the problem. It's very blurry. It's not very clear, and yeah, it's not defined, right? But by chipping away at this marble block, by chipping away at this problem, we discover the contours, right? And we can slowly begin to define the problem in more concrete terms. We discover the problem in this big block of marble, right? And it's an iterative process. We start off and we don't know anything, but the more we model, the more we describe our problem, the better the model is. So there are lots of tools to do this, but I think value objects probably my favorite, right? So what are they? So obviously they're objects that represent values. They're value objects. But what makes a value object a value object? So a value object is an object that has no identity other than itself. So what do we mean by that? So it has no identity other than itself. So 7 is a value. If we change it to 8, it's not 7 anymore, right? That's kind of clear. If we have a value object which is an IP address and it represents 127.0.0.1, if we change that to 172.7.0.0.2, it's a different IP address, right? You're not talking about the same IP address. On the other hand, if you've got an entity object and you change a property on the entity, it's still the same entity, right? You've still got the same order. You change something on the order, it's still the same order. if you change anything about a value object, it's a different value object. It's a different value, right? So this is an identity. It identifies a physical piece of network hardware, right, on the network. I don't know how networks work, but yeah, I know that much. Yeah, so 127002 is a different value. So the identity of a value object is the sum of its parts. Nothing more, nothing less. You know, that it's the everything in a value object contributes to its identity. So some code. So this is the simplest example of a value object, right? It's just representing an integer. Now, I don't necessarily recommend that you model integers in PHP. I mean, you could do. You might have reasons for doing so, but probably you don't. But it's a very simple example. This is it. So when people are discussing, like, oh, how do I add a value object in Laravel or in Symfony or whatever, it's just like 2 seconds. You've done it. Congratulations. Perfect. But of course, that's a very basic example. So let's have a look at some value objects in the wild. So a date. So date, and it's got 3 components. It represents a specific day in the year. Now you might ask, why not use a date time? So date time it's got the date in it, but the problem is it has a lot of other things too. You know, it's referencing like a time zone data. It's got lots of complexities. It's got all this parsing logic, and it comes back to this modeling thing. Depending on what we're building, if I'm building a timesheet, right, and I've got a list of days, you know, do I need a date time object to describe all those? You know, is that useful? Am I going to have time zones in this? You know, probably not. So this is just an example of, you know, modeling your problem. If your problem needs year, month, day, then create an object that represents that problem, right? Don't jump immediately to, you know, a very complicated thing like the date time object. Money. So I guess people have used a money value object. Yeah. It makes sense, right? So there's no absolute concept of money, like 100 somethings, right? So you need a currency. And these 2 things belong together. And we combine them together into this value object, which represents this abstract concept of money. A geolocation, so a specific point on planet Earth, or I guess other planets, I'm not sure. But, and a color. So again, this abstract concept of a color. And in this case, we instantiate it with a static constructor from 3 values representing red, green, and blue. What about this? Is this a value object? So a value object is something that has an identity and it sort of represents something, right, quite specific. Here we have 2 addresses, and the second one's got a typo. And yeah, you can look at that as a human. You can think, oh, it's the same address. It's got the same postcode. So it's the same address, but is it a value object? And I tend to think, you know, maybe that's not a value object because, it's just, it's nothing concrete, right? You can't compare. They're not the same. One's got a typo, one hasn't. So is it a value object? Is it not? It doesn't matter. So at the end of the day, does this solve your problem, right? If you need an address with 3 lines in it, you create it. It doesn't matter if it's a value object or DTO or anything else. Your problem requires that you create this object. Your problem should be leading you to your solutions and not the design patterns, right? So at the end of the day, you know, value object, it's a tool that you take from your toolbox, and you use that knowledge, you use that concept to solve your problem. But it's not to say that you should rigidly stick to, you know, your model defines what you should be building and how you're coding, not the design pattern, right? So if you need this, just create it. It doesn't matter if it's a value object or anything else. But you might borrow things from value objects to create this, like immutability and, you know, static constructors and other things, which we'll see later. So solve your problems first and argue about terminology later. So what about this? This is an order. It's not a value object. This is actually an entity. So has anybody heard of it? You've used ORMs, right? So an entity is something that has an identity. An entity is something that changes over time. So as we mentioned earlier, the order, it'll have an identity, and this is a value object, right? So UUID. But then it can have state, and the state can mutate over time, unlike a value object. Don't know what's coming next. Let's see. Okay, yeah, so this is kind of the virtues of value objects, right? So immutability. So if you don't take anything else away from this talk, take this. If you create a value object, just make it mutable. You can make mutable value objects, and you've probably used mutable value objects. Who's used like datetime? Everyone's used datetime, right? It's mutable. And it was such a bad idea that they had to introduce datetime immutable and then say everybody should use this because value objects should be immutable. So obviously with the datetime, that's the mutable version, you get it and you mutate it, and then your order has changed, right? Because it's changing it by reference. It's changed by reference everywhere. You're mutating this state, and that's obviously an egress for bugs into your application, having that mutability. By making these immutable, you protect yourself entirely from that sort of bug. But also, it doesn't make sense to update the value of 7. If you've got the value 7, you don't change the value of 7 to 8. You replace 7 with 8. You replace an IP address with another IP address. You replace one color with another color. You replace these things. You don't change their values. They're internal values. So immutability, that's the whole talk, if you want to leave it at that. But correctness. So another fantastic thing about value objects is that if you get a value object in your code, you can be, theoretically, 100% certain that it's valid, that it's got a valid state. And we do this by validating with defining constraints in the constructor. So a color, if we're constructing it with red, green, and blue, then these values should be between 0 and 255. And yeah, we can validate that in the constructor one time. If we're passing around RGB separately, individually throughout the entire code base, obviously you can have -2, you can have 300, you can have 500, and you could validate that every time, or you could use a value object and just create the value object. If you've created the value object, it's valid. You just do that one time, and any way you see that value object, you know that it's valid. That is an enormous benefit. So not quite as important, but very interesting. So static constructors. So I'm sure you've all used static constructors. So a static constructor is just a static function that instantiates your class. It's an alternative to using the public constructor. And in fact, in this case, I've made the constructor private. So you can only create the color, and this is what I tend to do with all value objects. I make it so you can only create them through the static constructors. So we say color and from RGB. Why? So most value objects can be created from different representations. So if you have a color, there's different ways to represent a color. You can represent it as HSV, as RGB, as the string green, the string blue. There's lots of different ways you can represent a color. But the internal value of the color is hidden, right? So we can say from HSV, and internally it will convert that to RGB. So we can say color from RGB, from HSV, from hex, and we have no idea. We know we've got a color. We don't care how it's implemented internally, right? So that's quite cool. But it gets even better when we realize that we can do this in 2 ways. So we can say from hex to hex, obviously. But we can also say from RGB to hex. So we can use the value object as this intermediary to convert to this abstract color concept, and then from it. So we can always go from one thing and to the other, which comes in handy. And we can have values in values, right? So in factor, we have a byte offset. So a byte offset in factor represents a point in a text document. So if you've got a text document and your cursor's on, I don't know, line 20 on column 30, then it's on a byte offset. So if you were to read this amount of bytes of the document, then the byte offset would be where your cursor is, if that's where you're reading up to. And then for a byte offset range, if I was going to select a function or select a variable, that would be represented as a byte offset range. And of course, I'm using byte offsets. So a byte offset, yeah, it's just an integer really, but it can't be negative. That's about the only constraint that it has. But we can also have this byte offset range. And we can say from byte offsets, and this is actually incredibly useful, as we'll find out later. And we can also kind of shortcut as well. So instead of saying, yeah, from, and having this boilerplate, which mostly you'll see in tests, right? You can just say from ints. So we say byte offset range from ints. A little thing, but it makes a lot of difference when you're running tests and things like that. Okay, so let's talk about smell. So we've talked a little bit about like what value objects are and why they're nice and yeah, why they're good. So let's have a look at some of the code smells, some of the things I consider to be code smells. Or let's look at some of the things you might see in code and how you might refactor it. So yeah, make payment. You'd expect to see something like this in legacy code, right? So we have an amount and we have a code. And it's a money, right? Easy. So the problem with having the amount in the code, why is it a problem at all? Well, the problem is that they vary independently. So the calling code is going to get an amount, presumably from the user somehow, or from the database, and it's going to get the code also from somewhere, right? Probably from the same sources it came from originally. But then they can vary independently. So you could very easily replace code with a different code. You could replace the amount, you could perform arithmetic on the amount, you could do all these different things, but they're going to vary independently. They don't stay together. So you can very easily end up with bugs because the wrong thing goes in there or the wrong thing goes in there because the things are not coupled. So combining them in a value object, you ensure that they stay together. So it's an example with more variables. So this is interpolation. So this is taking two colors and then we're going to return a color at like a, what do you call it, a percentage, right? So 0.75, we're going to return the color that's 0.75 into this color range, right? So what can we do? So we've got R1, green one, blue one, R2, green, yeah, obviously, right, colors. And it is fun going through code and just seeing this. You say, oh, look, I've just made the code instantly better. I mean, that's unarguably easier to look at, right? Apart from anything else. But can we go further? Can we go further? So turns out we can. We can introduce color range. So we're looking at this and we think, what do these two things represent? So we've got interpolate, one color to the other color. That's a color range, right? Brilliant. So now we've taken this, we've reduced it from like, I don't know, 7 arguments to 2. But we're not done yet. So we've got color range, we've got the amount. And we've got this interpolate method, and we've got this color utils class. Has anyone used the utils class? Yes, it's something you do because it feels dirty, right? It doesn't feel right. But you do it because there's no other way. But how can we make this better? So we interpolate the color range of we can move this interpolate method to the color range, which is fantastic. Because then we delete this entire class. Color utils, just throw it out the window. We can put the interpolate method on the color range, so we get the color range, we create it, and then we call interpolate, and we pass a single argument to interpolate out, and then we get the result. So just by, this is the amazing thing with refactoring sometimes, right? We started with this, we didn't know we were going to end up there, but by applying gradual refactorings, it's only when we get here that we realize we can do that, and we can get rid of that horrible color utils class. We realize that we don't need it anymore, right? So we really, we find the solution, we find out the way to represent our problem. And of course, if that looks verbose, you typically see something like that in tests. When you're actually using the code, it would look like, so if we've got a chart, and I don't know why you'd have a color range on a chart, maybe you do. You just say, give me the color range, interpolate it, give me the new color. Like, it's almost beautiful, right? So great, so we've got center map, and it's got longitude and latitude with all the problems that we already discussed with that approach. Makes sense, right? Geolocation. And then we're going to refactor it more. So we're going to move center map to geolocation. Yeah. So what's wrong with that? That doesn't make any sense, does it? So we've got the geolocation, and we're going to apply the refactoring to move the center map thing to it. But that means that the geolocation knows about the map, which is kind of weird. I mean, you'd either have to inject the map service into the geolocation, or like use a singleton or something, and that's very bad. Incidentally, the void return type is interesting because it means that this function has side effects, right? If you have a void return type, it means that function is either doing nothing or it's doing something, but it's certainly not returning anything. So that's a very good sign that this function is doing something external, right? It's having side effects on the outside world. And value objects should never have side effects on the outside world. They should be pure in the mathematical sense. So if you call a value object 100 times with the same arguments, you should always get the same response. So the solution, of course, is to just use a map service or whatever you want to call that, and pass in the geolocation value object. Okay, so operators. And I'm almost guaranteed to do this talk much faster than I rehearsed it, so which is great, so we can go down the pub quicker, right? So operators. So operators, you know what an operator is. So an operator is the plus sign, right? An operator is the division sign. And these are operands, not that it matters. So we've got foo.bar. And these are the native ones in PHP. We can also use the equals operator with objects in PHP. So we can have our color red, and we can have our color red, and we can say they're equal in PHP. This kind of works. But what if we say greater than, right? In PHP, we can't overload operators. We can't say that, yeah, this value object, this object can be compared with an operator, the greater one. It just doesn't work. And if it does work somehow, you can correct me later, but I don't think it does in any way. And also, does this make any sense? How can red be greater than red? How can red be greater than yellow? In what way is it greater than yellow? How can red be multiplied with another color? And maybe if you know about colors, I don't. Maybe you say, oh, Dan, of course you can multiply colors. I'm pretty sure you can. I just don't know anything about that. But the cool thing with value objects is that we can add these operators ourselves. So we can have equals, right? That's the sort of basic one. But we can also have domain-specific operators. So brighter than, we can't say that red is more than light red. We can say it's brighter than light red. So we can, again, we come back to this modeling thing. We're discovering this terminology in our model. We're discovering things and we're defining them. So we can say, yes, like these colors have this attribute called brightness. And we can say it's brighter than something. What's that? Don't ask me about colors. I have no idea. Yeah, I did say that. It might be false. And of course we can mix. So we might not be able to multiply a color with another color, but we can mix a color with another color, right? And we always get a result from that. So maybe a word about contextual equality. So we can see we've got equals, but why don't we just use the PHP operator equals for everything? So it turns out that things are equal in different ways, right? So if we take, for example, 2 blog posts and they have a set of tags, and one has the tags PHP and programming, and the other has the tags programming and PHP. They're the same tags, right? They're equal. They're unordered sets. But if you were to compare them in PHP with the equals operator, of course, it's comparing them as ordered sets, so it says that they're not equal. And the challenge is then knowing whether you can or cannot use the equal operator on your value objects, which is why it's probably a good idea to use equal to. Not just because of that, because then it opens up the expectation that you can use other operators as you need them. Yeah, so a counterexample would be a polyline. So this is kind of like a line drawn from points. And these are ordered sets. So these have the same points in different orders, but of course here the order matters and they draw different pictures, even though they've got the same data points, right? But they're in a different order, so the result is very different. Okay, so bad practices, which is what I thought the last section was about, right? I mixed it up. The bad practices, so these are things that I don't like seeing in code, and they're also things that I've personally done and practiced in years past. So one of these is bypassing the constructor. So about 8 years ago, I learned that you could do this, and it was a revelation, and I used it everywhere. I thought it was amazing. So bypassing constructor means you can say you have a static constructor from RGB, and because we're in the color class, we can create a new instance of the color class, and we can access private properties so that we can directly set these properties even though they're private. And I thought this is a really good idea, and it turns out it's a really, really bad idea. So the problem is consistency. Here we have red, green, and blue, but every time, and this is a common kind of theme with technical debt, right? It's when you perform this, when you have to perform the same boilerplate over and over and over again, and every time you repeat it, it increases your technical debt and it's a risk, right? It's introducing risk systematically every time you write some boilerplate. So here the boilerplate would be assigning these to the private properties, which you can forget to do. You can forget to assign green. You could also forget to validate it. So you're losing these benefits of the value object. So you need to always delegate to the primary constructor, like always. By doing this, you can absolutely ensure that they all have the same validation. The from methods, the only thing they need to do is convert whatever they are to RGB in this case, right? Or to an integer, or to a string, or whatever, however you're representing this value internally. They have the sole responsibility of converting the value. They never validate it. So the validation always happens in the constructor. And this is how you can guarantee the validity of your value objects. So your constructor is a guard against invalid state. No extends or implements. Yeah, so this is going back to like my rant, like I've been in these meetings where people are discussing and implementing this. So they say, oh, let's add a value object interface. So does that make any sense? So based on what we've said already, like we've got a greater than, we know that colors, it doesn't make any sense for a color to be greater than another color. So why would we be forced to implement this domain, this horrible thing that doesn't fit into our domain? This breaks the entire concept of modeling by enforcing these silly constraints on our value objects, and this distorts our model, right? It prevents us from modeling the problem. Does it make any sense to say that this value object is equal to any other value object? Is a car equal to a color? A car's not a value object. I don't know why I said that, but you know, you can't compare different value objects against each other. That makes no sense at all. So value objects are not an abstract type. Yeah, they exist independently of other things, and that you should use them to describe the exact problem that you have. And the same for extending. Like, don't extend like a value object class. It really makes no sense at all. So no value object namespace. So this is like kind of more of like a critique of the way that projects are kind of started by default in Symfony, maybe in Laravel as well, and in every other framework that's ever been invented. So you have the source folder, and then you just have like your entities are in this folder. All your forms are in this folder. All your commands are in this folder. And of course, your value objects are all in this folder. But this is a way to create a project that will not scale. This is a way to create a project that will be legacy in like 1 or 2 years from now, right? I mean, it depends how big your project is, but projects have a tendency to grow, right? And this is not a way that will allow your projects to grow. So what's the problem? You introduce a feature and you end up putting some of that feature in this folder, some of the features in that folder, some of the features in that corner over there, and it's just this kind of mess, right? Like, where is the feature? It's kind of splattered all over the wall. So yeah, it looks kind of neat and convenient at the start, but it doesn't scale. So the way to do this isn't necessarily clear. I think every project is in a process of evolution, but you should always try and identify these kind of boundaries in your code, right? And that makes it very easy. So where do we put our value objects? Well, you put the value objects where they're needed. So if you're designing a charts module or you're modeling a chart, create a charts namespace, and your value objects go in there, right? Put a collection in there too. You've got value objects and collections. You know, you put a factory in there. It doesn't put everything in there until it gets crowded. And then you need to refactor and say, okay, I now recognize that this category of object exists, and I can put that in another set namespace. But initially, this gives you the chance to, like, one of the problems I have when I join a legacy project is like, where do I actually start developing? I need to implement this class. Where do I put it? There's nowhere to put it. It's just entities and forms and all this sort of thing. Do I put it in the root namespace? I'm the only person that's ever put something in the root namespace. And it just becomes very difficult to maintain. I should just be able to say, okay, I'm going to create this folder for the thing I'm doing, and my stuff goes in there. Job done. So you need to give yourself the space to solve problems. If you're trying to like solve a problem in the sardine can, it's very, very hard. And incidentally, this also solves problems like, where do we put our value objects? Where do we put our whatevers, our collections and DTOs? It doesn't matter if you've got a greenfield place to put them. Yeah, no value object suffix, like gradient value. I've seen this quite a lot in code. You know, people say, this is my invoice number value object. Like gradient value, like, that's much better. Gradient from colors, color from RGB, gradient value object from colors, color value object from, no, don't do that. I mean, it might make sense, you know, with other types of object, like you might have something entity or something DTO. I tend to take that pattern, but these are kind of external things to my model. These are about persistence. These are about serializing data that are coming into the system. Then they're secondary concerns. Like value objects, they're part of your model. You're modeling something, you're modeling a problem. You should, the name is very important. So don't use the value object suffix. And I think this is finally, don't do this. So this is, in some ways, this talks kind of a rant about all the things that I hate. So from array and to array. So I see this all the time, and I've used it again personally. But this is such a bad pattern. I see it, and again, it's this technical debt thing. Every time you implement from array and to array, you introduce technical debt because you're repeating boilerplate that is prone to bugs. So we get an array of whatever, like it can be a list of numbers, it could be a hash map of, like a dictionary, and it could have any sort of types in it. So every time we have from array, we've got to figure out ourselves. It should have the currency key, it should have the amount key, it should have the currency should be a string, the amount should be an integer, and this is fallible. It's very fallible. And what's more, the error message you'll get from this is going to be crap. Like, it's not going to be a useful error message, and even less will it be consistent as you go forward. And of course, if we're doing serialization, which is what we're doing, to array should be consumable by from array. Right? These two things should be kind of, interchange. They should feed back into each other. And you've got to ensure that guarantee as well. So it's a long way of saying just don't do this. Just use a serialization library, right? But this is a hard problem. So don't use to array and from array. Just use a library that does that for you because they can do it very, very, very well. So mocking, so who uses mocks? Okay, I'm probably the only person that doesn't, and which is fine. I won't judge you. But there's basically two classes of test-driven developer, right? There's the test-driven developer that uses mocks, and there's the test-driven developer that doesn't. They use real implementations of classes instead. Yeah.
Using mocks to mock external dependency, not internal. So something like this, you wouldn't use a mock for.
Exactly. You're the enlightened test-driven developer that I'm talking about. So. So, yeah, it makes no sense to do this. Absolutely no sense at all. So neither one of these schools, which sometimes fight, right, in a nice way, but neither of them want you to do this, right? Neither of these schools want you to create an entity, a DTO, a value object. It makes no sense. They have no dependencies, right? These things exist in their own right. Why would you mock 7? Is 7 going to have a different value tomorrow? It doesn't make any sense. You're going to say color will return this, but that's not red, right? So why would, it doesn't make any sense. You're just wasting time and you're writing code that's going to be harder to maintain. And also you should make your value objects final, and then this becomes impossible unless you use a horrible package from packages to work around that. But yeah, don't mock value objects, don't mock entities, don't mock anything that that has no, and don't mock anything that's pure, right? So don't mock anything that has no external dependencies. It doesn't make any sense. So yeah, it's either this or just that. Writing tests actually becomes a lot more fun when you've got a rich domain, right? Nobody wants you to do that. Okay. So to finish off, so value objects should be immutable. Thou shalt not change, but thou mayest spawn new versions of thyself. So yeah, you can't change 7 to 8, but what you can do with value objects, you will often see that they have methods that look like they mutate them. So you might have an integer value object, and you might say add another integer one to it. What it's going to do, it's going to return a new version of itself. So a new instance, which is 8, right? So you can create new versions, you can spawn new versions of value objects and mutate them, mutated spawn versions of the value objects, and that's fine. Value objects should be correct. Thou shalt not bear false representation. So yeah, you're given a value object, you always know that it's valid. You can just take it for granted that it's, and if it's not, if it doesn't have validation, you need to add it, right? Be isolated. Thou shalt not associate with false prophets. So value objects should be pure. They shouldn't have any external dependencies. Which, funnily enough, is what that one says. So I'm not sure what the two are different. Thou shalt not associate with false prophets. Be functionally pure. I think it's the same thing. So yeah, you should be able to call a method on the value object until the heat death of the universe, and it should always return the same value given the same input. And be unknowable. Thou shalt not reveal thy true self. So what this means is you should, when you're calling a value object, you should have no idea how it's internally represented, right? This is why we make the constructor private, so that we don't say new color RGB and then from HSV from HSL or whatever. So nowhere in your code should the developer using your value object know how it's represented internally. And this makes it very easy to refactor it. So you can completely change the internal representation of your color, of your IP address, or whatever it is. And nothing else has to change, right? So you've isolated the internal value. Yeah, but don't listen to me. So all these are opinions, right? They're quite strong opinions, and I've been doing this for quite a long time. And I think people generally agree with these opinions. But they're all heuristics, right? This is all heuristics. I mean, you might find an occasion to do things that I've said not to do here, and that's fine. It's all about solving your problems and doing whatever you need to do to solve your problems. And a lot of development is about making mistakes, right? There's no good developer has consistently done good things throughout their careers or through the a big part of learning is making mistakes, and it's actually and that's how you form opinions as well. You try something, you realize that it's not working. What works for you might not work for somebody else, and vice versa. But over time, I think the good practices tend to shine through. And finally, value objects are just really easy. But while being very easy to implement, they're extremely powerful, and they add a lot of value to your code. So that's the talk. If you really want to, you can scan this barcode, or you could write that down with a pen. And yeah, there's a blog post on there and a few links to some other resources, including the blog post that I wrote. It's got a dinosaur in it, I think, and some other things. Yeah, and that's it. So yeah, happy to take any questions, or just to start drinking a beer, really.
Got any thoughts, for the colour you had from RGB? Or
Red.
Yeah. But if you're going to have, like, from a name.
Yeah.
String, and it's, there's hundreds of them, isn't there? At what point would you say maybe this is too much to fit in a, would you have a colour factory where you give a string that says colour object?
I mean, that's, yeah. I mean, the classic example for that would be the datetime object, right? Yeah. Like, does your value object contain the entire time zone database for the entire world? And also that changes, right? That's a mutable thing. So, yeah, I think it becomes difficult. And I think some program languages approach this in different ways, right? So in Rust, you have like this naive datetime object, which is really literally like a datetime object, and you have one that's slightly less naive and like a bit more spiky. And it's sort of, yeah, you sort of bend these rules. Like I say, these are heuristics, and like most of the time, you definitely do not want to have a database call to get the time zone database. But there's always exceptions, right? For the color example, yeah, why not have like your 16 ANSI colors in your value object? Why not? Why not have I don't know, like 256 colors strings in your value object. Like, why not? But if you need to maintain a list of like all the color names in the color encyclopedia, then yeah, you just use your common sense, Yep.
What is the difference between
So that's a good question, and it's about the value. So, like a DTO, it's representing like a splurge of fields. It's representing like an API surface, really. Like it's not representing like a value, like 7 or an IP address. It's not an identifier. Sorry?
It's not such a specific concept.
Yeah, I mean, a data transfer object is literally for transferring data. I mean, there are similarities, as with lots of these objects, right? So DTOs can be immutable. You might want to make them immutable, but they could also be mutable. It's not like a big thing. That's pretty much where the similarities stop, actually. So you wouldn't bother with validation necessarily in the DTO, but you might annotate it. Yeah.
I was thinking that if you zoom really far out, they're sort of similar in the sense that they are.
Yeah. But a value is more, it represents something discrete. And you wouldn't know from the outside what's in the value. It's about the representation of this abstract concept, right? You wouldn't have any idea what's inside that value, whereas a DTO is very public about what its structure is, right? Okay. Then there's no more questions, then I'll say thank you. Yeah.